In the last video, we got an idea of what the standard deviation is measuring. In this video, we will look at the math that actually occurs when calculating this measure. We will work with data to calculate this measure as well as associate notation with it. It is worth noting that after this lesson, you probably won't calculate this measure by hand ever again, because you'll learn software to do it for you. But calculating it yourself will give you intuition behind what it's actually doing. And this intuition is necessary to become good at understanding data and choosing the right analysis for your situation. Imagine we have a data set with 4 values, 10, 14, 10, and 6. The first thing we need to do to calculate the standard deviation is to find the mean. In notation, we have this as x bar. For our values, the sum is 40, and we have 4 numbers. So the mean is 40 over 4, or 10. Then we want to look at the distance of each observation from this mean. 2 of these observations are exactly equal to the mean, so the distance here is 0. One is 4 larger, the 14, while the other is 4 smaller, the 6. In notation, each of these is xi minus x bar. Then, if we were to average these distances, the positive would cancel with the negative value, and the value of 0 isn't a great measure of the spread here. 0 would suggest that all the values are the same, or that there's no spread. So instead, we need to make all of these values positive. The way we do this when calculating the standard deviation is by squaring them all. If we do that here, our negative and positive 4 values will become 16s. Now, we could average these to find the average squared distance of each observation from the mean. This is called the variance. Finding the average, just as we did before, means adding all of these values and dividing by how many there are. In our case, we had 0, 16, 0, 16, and we divide by 4 because we have 4 observations. However, this is an average of squared values, which we only did to get positive values in the first place. So to get our standard deviation, we take the square root of this ending value. Here, our standard deviation is 2.83. So this is, on average, how far each point in our data set is from the mean, which is the definition of the standard deviation.